going on this week, and wanted to just run through some things kind of quick. I mentioned to some of the folks who came in early that I have some family in the house, so I don't want to. I don't know if we're going to be here that long tonight, but I have some things I do want to share with you guys this evening. Anybody got any questions or comments or anything to say at the beginning? Anyone? I see a hand. Is that Roger or Chris? Can I tell? Roger, can you unmute yourself and if you got your hand up?
My bad. I didn't mean to have it up.
Oh, okay. That's cool. All right. So I've done a couple of things. I did put a very short PowerPoint slide collection out there that I think you're going to find kind of interesting. And we'll talk about that in just a little bit. And I also mounted a page that is kind of it's a, I guess you call it a legacy page from an old web page that I used to manage, a set of pages that I used to manage that were the departmental pages in Department of Geography here. And it has some links to some kind of cool things. We'll take a look at it later on, some kind of cool web mapping things that are going on. I don't really have access to the server that it's on anymore, so it's still on a server at DePaul, but I can't really get easy access to it, so it's not editable, but it's still holding on pretty well because all of the stuff that's in there is pretty much, they're mainly KMLs and KMZs. So we'll talk more about that a little bit later on. At this point in the term, I think we're over the hump, kind of, we're sort of past the midterm, if you call it that. It's such a short term, it's hard to imagine, that you have these different segments of it, but activity 3 is all in, final project part 1 is all in. And I'm working on those. I'm slowly sort of getting organized and working on the grading. Activity 2 is due, I believe Sunday. It's the 27th. So I think that's Sunday evening. And that's the one that is with the OSM, the crisis mapping activity. And if anybody's having any issues with that, if you're having any problems, or if you have any questions, please contact me. We can set up a Zoom, or we can, we'll have a conversation of some kind, and we can, I can try to help you out with that. I have a number of years experience working with them. So this is something this is like when this is my one opportunity to use this this bully pulpit as a way to maybe sort of have some of you guys find this to be something that maybe you'd be interested in doing, because I think it's kind of a neat thing to do, and when you start getting some skills and doing these kinds of things, and it's a way to learn about the world too. So I hope that everybody can take the time to get involved with that and get interested in it. No one's turned anything in on it yet. No one's asked any questions about it yet. So I'm open to questions. Activity 4 is due, also coming up fairly soon. It's due March 3rd, 3/3. And activity 4, you're working with the data that you collected from the toxic release inventory, and you're taking that and turning it into something that you can work with and map. And so you're kind of getting, this is a nice way to make sure that, we have good working data, and that you go through the process of cleaning and organizing the data and learning about it, and maybe doing a little bit of background research on the stuff that you have, whatever county you're working in. Most of you are in Cook County, but some of you are in some of the suburban counties as well. So activity 4, it's for that, purpose, really, to give you a chance to work through that, get it ready for the final project part 2. And so that will be the final project part 2, and activity 5 are both going to drop sometime over the weekend. So that way, everything's going to be in front of us. You'll have everything that you know that you need to do to complete this class, and to complete it well, to finish strong. Just be looking for that, and I'll be in touch over the next week about that. We also we do have a final quiz coming up, the 4th quiz 4, which is going to be, probably we'll do it for 2 days again, because it that way everybody will have be sure to have time to get online and to take care of that. And that's coming up on March 11th, which by then, probably there's going to be flowers out and daffodils and everything in Chicago. Any questions about any of those different, and the final project part 2, the due date has been in the syllabus since the beginning of term. It's the final project, the large part that you're getting a chance to work with on activity 4, and then you're also going to be completing just a stunning map composition, but also showing me what you've learned about mapping and about working with data, and writing about it a little bit. So, in a short paper that goes with that, about a 1,200 word paper that will go with that. So, and I can talk more about that, and probably will. I'll probably be posting a YouTube video or something, with some more tips and kind of hints and a little bit of rah-rahing about the final project. Because final project, we don't have a final exam in this class, and the reason for that is the people who are in this industry, in the geospatial services, location-based services, and also academics as well in graduate schools in geography. What they want to see is, they want to see projects. They want to see, and they want people who are being trained to use this and educated to use this technology to be able to go through the process of all the different parts of completing a project. So, because this course is the first in a 3-course sequence, we want to get everybody kind of with a good start. For some people, this will be the only GIS course they'll have. For others, they may go on and take other GIS courses with other faculty. The other faculty we have in GIS are brilliant, and they're really good teachers, some really good, good folks in our department. And the other courses, they tend to be a bit smaller, and they tend to be more in depth, certainly more programming, if you're interested in that. If you're not, it's pretty fine, actually. There's ways to work around that. But we'll talk a little bit about that tonight, even as we're going forward. And we just have some really good faculty in GIS that are teaching. By the way, I wanted to mention, and I'll share a little bit of news with you, but Cassie Follett, the GIS coordinator, has been out for a couple of weeks. She's been ill. It's not COVID related, it's something else. And it was it was very, it was kind of stressful for everybody in the department, just because we like her so much, and we were worried about her. But she's coming back. She's slowly getting back, back in the swing of things, and she'll be back in full force here, probably within a week or so, and will be available for helping out with some of the problems that you guys are having, or concerns. So any questions before we start the stuff that we're going to do today? Anybody? All right, cool. So let me I think I'm sharing. There we go. So I wanted to talk just a little bit about web mapping, and this is something that I think as you go through further, deeper into geospatial services and location-based services and GIS more specifically, you're going to be involved in different kinds of web mapping, and what the internet is a platform for making different kinds of visualizations, different forms of database access available to the public. And so, some of the things that we'll do in here, what we're doing is we're sort of building a foundation for you to go on and do the sorts of things. And it may involve, app development. It may involve making solutions for clients that need custom built geospatial applications or technologies that can be deployed in their workplaces to make their workflows more efficient and to benefit the work that those folks are doing, and perhaps to within the organization that you'll be working in. So a lot of that is done through the internet, and not just through the internet as deployed through browsers, the sort of traditional or typical browsers, Safari, Chrome, Netscape, Firefox, all the different browsers that people use. There are other browsers that are really, if you'd call them geospatial data browsers. And so things, for instance, like Google Maps and Google Earth, Apple Maps, and other mapping platforms. Here, Map Creator, here is a company here or there for me in Chicago, big company, one of the companies that has partially monopolized the geospatial data industry. So we're in this class, we're going to take a look at some different things of some different parts of this just real quickly, a very light coverage of this, and just think about some of the different categories of what kinds of web mapping there is. So right here we're looking at this is a web map that we made a few years ago, and it's a visualization of the amount of toxics that were being released in Cook County in 2004. And so the height of each of these little towers with the little blue dot at the top of them is proportional to the amount of toxics that were released by these different facilities in Cook County in 2004. You're going to be stunned. We'll take a look at a couple of these through a geospatial browser, and you'll be amazed at the numbers that we were looking at just 15 years ago or 15, 16 years ago in Cook County. It's actually, I mean, things have improved substantially, at least in terms of the amount of toxics that are being released on site by different firms. So there's different types of web maps that we can think about. There are analytic web maps that you can use to extract analytical information, or that you can do analytical work. You can answer questions with the geospatial data sets that you're working with. There are animated web maps that have animation that work more or less as videos. A lot of these we see in, we're very familiar with. We see it in meteorological or climatic visualizations of different physical processes in the atmosphere or the oceans, or sometimes sometimes remotely sensed images in in animated fashion that helps us to understand how these processes unfold, how they work. There's collaborative web maps, and you guys are working on one. And Activity 4, hey, I put in another plug for Activity 4 and the OSM crisis mapping that you guys are doing. So there are a lot of these, and not just the the OSM. There's another platform that I have some familiarity with, that started in Kenya in 2007, I believe, with the post-election violence in 2007. It's where it started. And it's funny because I've read academic papers where they say it started with the Haitian earthquakes, and no, it didn't. It started about like 3 years before that, I think, in Kenya with post-election violence. And that was really the inspiration for that kind of crowdsourcing, collaborative web mapping. And now it's used for all kinds of things, for just lots of different things. But the data comes from crowdsourced data that is sometimes it's volunteered, as in the case of the OSM mapping, but at other times it's kind of stripped off of anonymized web feeds or anonymized social media data feeds like Twitter or some of the other social media platforms that allow that kind of anonymized data collection. There's online atlases, and the atlas is kind of an ancient way of putting together geospatial information, but online atlases have become very popular, where you just have collections of maps, usually pretty much static maps that are packaged in some kind of thematic form, where they're focused on a particular place or a particular phenomena of some kind, physical phenomena or human social phenomena, something that's happening. And then some web maps are more or less real time or near real time. In other words, the data that we're looking at is practically a live feed, and it's a live geospatial feed. We see a lot of this in meteorological and climatological mapping, meteorological especially, with the tracking of storms and such. But you also see it with things like the traffic mapping, which has become a huge industry in the United States and around the world. Really, we're tracking traffic all over the world now, and we'll take a quick look at how a firm that does that and how how they do that. And then there's also just static web maps that are posted. Kind of like, I don't know if you guys have seen story maps, but the ArcGIS has its own platform that we can access, and we do more of this in GIS2 and GIS3. We do more, and then there are other courses. We have an entire course just on web mapping that Cassie teaches, Cassie Follett. So there's really a lot to this, and it's something that changes. It's like every time that I've taught 141, I think since we started incorporating web mapping, or at least introducing the notion of web mapping to folks, it changes every term practically that we do this. So analytic web maps, this is an example of a meteorological, a radar image that's being presented online. This is an organization that we actually have a weather station on the roof of the 990 Fullerton building that I manage. I think I still manage. I'm not sure who's managing it. I do it kind of remotely. And it's up, if you're ever out on Fullerton and you look up at the Deeskin building, the 990 Fullerton building, there's like a little shack, sort of penthouse that's on the back part of the building that's like the 5th story. It's right where the stairs are. So our weather station, if you look up there's a weather station up on top of that. And it's pretty much the official weather station for Lincoln Park, because it's a good weather station first. It's our 2nd generation station. I put it up there and have been managing it since 2007, which is not that long ago, but it's like 14 years or so. And we have 14 years of continuous data, meteorological data for that location that is on the internet through the Weather Underground. So the Weather Underground is it's an organization of kind of weather nerds and climate nerds that collect data and publish it online through the Wonder Maps. So the data that Weather Underground has, they use it for a variety of analytical purposes. And this is a map. It's really interesting. It really caught my eye when I first saw it. But if you look at it, you're looking at precipitation intensity and in these polygons, and also precipitation start time. So how long has it been since precipitation started as this storm moved through? And then those data are attached to polygons. Now, I got excited because the polygons, when I looked at them, they were obviously a type of polygon that when you're a geography nerd, you know all about. Can anybody tell me there may be someone who's had a geography class before. Can anybody tell me what kind of polygons these are? Anybody want to shout out? You look at it and you can tell that's what's going on here. Okay, probably not. This is kind of for space nerds and not space, outer space, but space, 3-dimensional space nerds like me. But these are called Thiessen polygons, and so Thiessen polygons, each polygon is centered on a Weather Underground weather station, and the polygon is constructed in a way so that every point inside each polygon is closest to that weather station. So it's a way of constructing polygons that are spatially linked to a point location where you're collecting data. So it's a way to kind of transfer data that's being collected at a point to an entire area of interest that you're mapping. So decent polygons, they're pretty cool. It's also animated web maps, right? So this is the US weather radar from the National Weather Service. I think it's still working. And this is the current map for the United States right now at 4:42 p.m., I guess was when it was updated. And then the animated map itself, we can see it looks like down through Kentucky, looks like they're getting some thunderstorms moving through the state. They're still recovering from that tornado outbreak and that incredible tornado that just devastated the state about a month or so ago. It was this horrific storm that happened that the tornado passed through 4 states and was on the ground for over 200 miles. Most of it in Kentucky. It went right up through the state. So, animated web maps have really revolutionized the way that we certainly visualize weather, which is, an incredibly important physical phenomena that we all sort of have to deal with in different ways. And some of us, more so than others, have to worry about this. But again, animated web maps are used quite a lot in mostly in where I see them mostly is in meteorology and climatology also. And let's see if I can get back to where I was. Yes. There's also collaborative web maps. And again, this is the OSM for Chicago, the OpenStreetMap for Chicago. It's an incredibly detailed map, but we also do have the humanitarian OSM team, or the HOT, as we call it. And the humanitarian OSM team is what you're going to be working on your activity 4 with. Let's see if I can connect with that here. Yeah, so this is a page that we have that I use, and it has some of the links that we have in our activity 2 that you guys are working on, that you're completing. This is the activity that wouldn't go away, right? Like the person that's sleeping on your couch, that won't leave, right? So this activity, but it's going to go away soon, and we're going to finish it soon. So if you look at this right now, just looking at there's different parts to it. There's mapping, there's validation, and then there's using the data ultimately. And, people use the data that we make in this project immediately. As soon as you publish that data, it's available to field workers wherever it is you're mapping. And right now, I think they have about what's 440 times 14. They have about 700 projects at least that you have to pick from. And when you look at them, you'll see that they're ranked from the highest priority to the lowest priority. So right now they have 29 pages with 14 projects on a page. Each one of these is a separate project, right? And these are all high, and many of them take beginning mappers. You can see you're going to start with one that is looking for beginners. And I'm still a beginner too, believe it or not. I've been doing it for a few years and I'm still a beginner. And I'm not that anxious to move on, even when I think when I do move on to an intermediate mapper, I'm probably going to still work on a lot of beginner projects. So, these projects, when you look at them, here's an example of one. I think I glanced at this one earlier today. This is in the Philippines. And so in the Philippines, this is the project, right? And you look at it, you go, oh, it looks like a piece of fabric or something. But when you actually look at it closely, you'll see that each of these little tiles is a project in itself. And all the white ones are wide open. They're ready for somebody to do some mapping in. So in this one, we're mapping, just as an example, we're working with youth mappers, which are coordinating it. And then, there's dozens of people that are working on this particular project. So this is just a great example of a crowdsourced a crowdsourced collaborative web map. And the OSM, they are a great nonprofit, and it's a data set now that's available to developers, people who are developing apps or developing. So it's being used more and more for different mapping applications because they don't charge anything for it. They give it away because it's being created by the crowd of mappers. Well, I didn't really want to go to the OSM, but here's the OSM. Again, gives you a sense. Anybody know where this is? Can you tell me? It looks like a city, doesn't it? Look at the OSM. Look at how detailed this is. Building.
What was the name of the city when you scroll out a little bit?
This one here.
Yeah.
There it is. I'm pointing to it with my cursor. We say it as Mogadishu. Mogadishu.
It's in Somalia. Yeah.
It's in Somalia, right? So it's in the coast of Somalia. So again, this is, you can work in projects all around the world. So the OSM it's a great project. Really is a great collaborative mapping project. And there are online atlases. This is one of my favorite online atlases. This is the national map from the U.S. Geological Survey. And this is the national map viewer. The national map's a great atlas. It is the national atlas. And they actually, this data collection was for many years published regularly as a huge, big paper, cardboard, bound, big, heavy book you could only find in the reference room at most libraries, and it was the National Atlas. But now they use it as a way for folks like us who need data or want data, and look who they're using. Do you recognize that? That's Esri's little. When you see those little pumping bars, that's from ESR. That's one of their servers. But they use this as a way to browse through their collection of data sets that you can download that are all in the public domain. The United States probably has the best public domain policy, certainly of any developed country. We give it all away pretty much. So this has really spurred a lot of innovation in the private sector. When somebody's giving you something that's incredibly valuable, digital geospatial data sets that are just exquisitely precise, you're going to be able to do some interesting things with it, right? Again, incredibly detailed data, and this is all in the public domain. It's in the National Atlas. So this would be probably my favorite online atlas, or certainly one that I've used the most. Does anybody got any questions as we're going along? Have I anything that I passed over too quickly or maybe not quick enough? Anyone? Okay, good. Let's see. Get back to my page here. And then we have real-time web maps also. And this is, an example of Google Maps traffic map. And we've all seen this. And Google doesn't really collect these data. They buy services from other companies in the private sector. Generally, that's where they get their traffic data. So they have all of the street network, but they, wait a minute, you can click that. They buy services from companies like INRIX, okay? INRIX is a company in Washington State that was founded by one of the founders of Microsoft, wealthy tech, probably billionaire. His name eludes me right now, and it is a man, I believe. But they have, for a number of years, had their finger or thumb on the pulse of geospatial services around traffic. And so they track vehicles, and they have large arrangements with private firms, with some public agencies, to collect data, anonymized data, in what they term probe vehicles. Now, probe vehicle for them, and there are other firms that do this. Here also does this, and they have traffic services that they sell that Google also buys. Here is a Chicago company. They have, I think, 3,000 or 4,000 employees down in the West Loop. They're in the former Boeing building in the West Loop. But INRIX, but they're the ones who, they're one of the firms and one of the principal firms who collects data from probe vehicles and collecting anonymized location and speed and traffic information, and agglomerating that into traffic information that they then sell as a service to firms like Google or other firms like big firms like the big delivery services like UPS, FedEx, and so on. They also buy the traffic data from INRIX and other firms like them, and that they use that data to produce the real-time traffic maps that we're used to using on our phones and in our cars, right? So this is that linked technology between having the databases, the geospatial databases of the street networks, the road networks, in great detail now, all over the world, not just in the United States, but all over the world, and a growing network, right, of global highways, other transportation corridors. To they use that data to make the world, we would hope, a more efficient place, right? A place where it's easier to get around, where things that move around are easily understood. It's easily understood how long it will take for things to get from one place to another place. If you're, the really mundane uses that we have for it, if you're going to a restaurant, we know that it's going to take 28 minutes to get there. So we have a reservation. So we leave, 27 minutes before the reservation, and we get there right on time, right? So, I mean, but that's a very mundane. Everything that moves now is moving with this kind of intelligence, and the savings in the economy nationally in the United States and globally now for the use of these kinds of services is numbered in the trillions of dollars a year that are saved in terms of saved time, not lost time, but saved time, and also save fuel and just other savings that you get because you're moving more efficiently, avoiding highways like the Edens or the Kennedy when it looks like this. Maybe timing things so that you don't get caught in these kinds of situations. But again, it's everything that moves now is moving with this kind of intelligence. Practically everything that moves is moving with this kind of intelligence. And INRIX is one of those firms that's in that, in that area. So there also are static web maps, and these are some of my favorite kinds. I do like these, and this is a particular static web map, and we made a number of these a number of years ago. Oh, wait a minute. That wasn't what I wanted. There we go. Yeah, so we made a number of these a number of years ago, and we have a page. It's kind of a legacy page that uses the Google Earth and Google Maps browser to view static geospatial information that is historical. So this is a page, and this page is available on our D2L page now, on the week 8 page. But there's some examples of these static web maps. This is one of my favorites. And so when you open these are either KML, keyhole markup language, or KMZ files. This is a KMZ, and these will open, and it's getting through Chrome. It's getting a little goofier because they try to, they're trying to protect us. But these will open in Google Maps. I'm sorry, in Google Earth. So if you've used Google Earth, you may have done this kind of thing before. But this is a Google Earth view of an aerial photograph, black and white, and you say, well, gosh, why we're looking at this old photograph? Well, this photograph is from 1938. Okay, so and we're looking at the south side of Chicago, so it's been georeferenced in Google Earth, and Google Earth is really a browser. It's a geospatial browser, and it allows you to put information, maps, images, and so on, historical maps, into their map of the world. So they give you the world, and they say, here, go ahead and put your maps, your data into our browser, our geospatial browser. And so what are we looking at here? We're on the south side of Chicago. What do you think this is right here, this facility here? It's 1938. Any thoughts, any ideas? Any of you guys from the south side of Chicago? Give me a shout out. Go ahead. Hello.
Is it a stockyards?
Yes, this is the Union Stockyards, which they're no longer there. So these are, you can see all of the stalls that the animals were kept in when they were unloaded from trains, which came through the switching yard over here. This switching yard is still here, but there have been some changes, right? And here's another, when you look and see these, you know, okay, this is pretty old, right? So this image is from 1938. So it predates all the expressways. So there's a number of things you can see here. You can see the stockyards and you can kind of see how they were laid out. But one of the nice things about this is, and this is what Google has given us, is we can take this image and we can go from 1938 to 2022. This is what's there now. And now it's kind of an industrial park. There may be some meat being processed in there. I really don't know. But it's not, the stockyards are gone now. So there's the stockyards in 1938. Here we are, 80 plus years later in 2022. And there's other things that you can see in this image that really give you an appreciation for how our city has changed when you think about what happened when the Dan Ryan Expressway was built on the south side. There's a baseball field there. And, when you see that and you realize that, when the Dan Ryan was built, there's the Dan Ryan, you can see it with automobiles on it. They pretty much took out at least 2 and sometimes 3 blocks all the way down all the way down through the south side, and anywhere that they built expressways on the north side or on the northwest side. Here's, what is that called now? This is on the south side. This is like, what, 35th, 31st? I don't know, 35th maybe. This is where the Sox play, right? Where did they play in 1938? Well, they played right here. This is just a little bit of Comiskey you can see here. So now it's, Comiskey was where the parking lot is now for the Sox new field, right? That's how sometimes things change. But look at the expressway there that just completely wiped out a huge part of the neighborhood and divided the neighborhood, right? It's pretty stunning. So, static web maps are pretty cool. Here's another example of one. And this is, we were looking at a static image of this, but this is it's static in a way. It is static, it's fixed, and it's georeferenced. But here's another web map. Oh, that wasn't the one I intended. Anyway, selected. It was this one, I believe. Yeah, this is the 2004 TRI data. And so there were hundreds of firms in 2004 in Cook County that were releasing TRI substances. And these columns or little pillars there are they're proportional to the amount of toxics that were being released. So the one that was right at the top of the heap, there it is. Envirite of Illinois Incorporated. And that's the number of pounds that they released in 2004, over 2 million pounds. That's the south side, down around Lake Calumet. Envirite. So again, there's a lot you can do with this, these types of, web-enabled data sets. And when you start thinking about Google Earth like a browser, it's it gives you sort of a different perspective on web mapping, certainly, but also on the possibilities of what you can do with these things, because these are not big files. You share that with someone, they double click on it, and they can open it in their browser. They don't have to have GIS. And there's quite a bit of analytical work that can be done with data sets that come out of the systems that we work with, ArcGIS Pro, and can be used in platforms that are free, right? Like Google Earth. Google Earth is a free browser, a free platform. Google Maps is a free platform. So they give us the world, and they encourage us to put our stuff in their world, in their browser. Let's see, where am I here? Yeah. So, there's a few links here. And again, some of the web mapping that you do, some of it is, it requires skills that are certainly beyond the reach of this class. These are the kinds of things that we do in, that we do in other courses that we have. We actually do have a course that's a Python programming for GIS course, great course that there's usually a long wait list of people to get into that course. That's taught by Professor Wang. Fabulous course, great teacher. I think it's one that you guys should be on the lookout for if you're interested in doing some coding and doing some programming. And there's another kind of channel for us in ArcGIS Pro, and it's called Model Builder. Has anybody explored Model Builder at all, or taken a look at Model Builder in ArcGIS Pro? Because it's there in your installation. It's kind of, it's not really hidden, but it's there. Okay, and I'll show you I'll show you where it is. Accidentally muted myself. Sorry about that. This link is to the help page for Model Builder that I think we can access. For some reason, I have to click these things 2 times. So this is a good start if you're interested in doing some coding. If you're a Python programmer, you certainly should be interested in this, I would think. And this is a good place to start, to take a look at the different parts to Model Builder. And I use it a bit. I've used it a few times, but I've used it more just to learn about how it works. And so this is an example. And again, it's changed. This is something that's been around for some time. It was a component of ArcGIS Desktop for the last 10 years or so. So there's a lot of stuff that's come out of that. But see this, let me get back to, yeah, I need to finish this guy. Yeah, so here's a model in Model Builder that I was tinkering around with a bit over the last few days. And so I'm kind of getting up to speed with Model Builder. And I'll show you this example in ArcGIS Pro. This is Pro here, and this is these are some data that I've been working with a bit. And the let me check and make sure. Okay, we're good. Still recording. Yeah, so this Model Builder is up here. In like if you're in a map and you look at the analysis tab, you can get, this is how you enter into Model Builder. This will open a Model Builder panel and you can start building models. And you build models by connecting data sets and tools and the output from processes that you've initiated. And they can be quite complex. This is a very simple model here that does a relatively simple thing. And I want to actually take the opportunity to also mention to you guys that I have found and located, and I'm working with the 2020 census data. So that is going to be available for your final projects. I'm trying to get it in an easily usable form. The census has changed a lot, as it does every 10 years, and it's the redistricting demographic profile, the same quote unquote the same data set, but it's changed a lot since. So it's not exactly the same. This is actually one of the bigger changes that I've ever seen in the data that is in the census and it's being made available to local governments, state governments, and so on for redistricting. But this is a dot map that just, I thought you might find this interesting. This is a dot map of population for 2020. So like this is where all the people in the 2020 census live. There's a dot on this map for every 500 people. That's the scale that I'm using on this. I did this as a dot map, but that's not really what we're interested in here. We're more interested in this model, right? So what this model does is it will take the let's see, it takes the Illinois 2020 TRI data, and let me here. Oh, not that one. I want to clear the selected, so I want to run the model. I'll show you just quickly what I was trying to do, and then I'll run. This is a simple model. Trust me, I'm a simple man, and this is a simple model. Yeah, there. So I have in this map, I have the county outline for Cook County. So I have a one polygon shapefile or feature class, I'm sorry. And I'm going to use that like a cookie cutter to select the the TRI sites in Cook County that were there in 2020. So this is all of them. It's not just the top 100. And it's all of them. It's actually all of them in the state. I think we may have looked at this before. We took a quick look at it last week. But yes. So this model, what this model will do, let me get to my model builder tool set. And I want to fit the model. So what this model will do is it takes the data from the TRI for 2020, takes the county boundary, and it selects this by location. So it uses this as a cookie cutter to select just the values that are the facilities that are in Cook County. And I actually found a data error in the TRI data, I think perhaps for one of the suburban counties. By doing this selection, I may point that out here in a second. So there are some products from this. You get a couple of different products. There's a count of the number of facilities in Cook County, and then you also get an output layer with the names, I believe, of the facilities. So that's another layer. It's an annotation layer. It's part of the output of this selection operation. And then you get a cached version of this data set, this layer that it starts off with about 700 or 800 facilities. And in this cached layer, it still has the same facilities, but the ones in Cook County are selected. And then I took that layer and I used that to create a buffer, so a polygon buffer around the 294 facilities in Cook County that were selected. And we'll see the results of that here in just a second. And then that produced this layer here that is a polygon feature class that's dissolved. You'll see, I'll show you what I mean by that here in just a second. I hope it runs. I think it will. So first I'm going to validate it. So it checks over the model to make sure that all of the connectors, and I built this model literally by dragging data sets from the map and dragging tools from the toolbox. And don't blink here. This is the ArcGIS Pro toolbox. Each one of these is a separate program or module that runs independently. They're all written in Python. Okay, watch. So these are all the tools that you have available to build widgets. Digits to widgets, okay? So you can just take those things and drag them into this space, connect them with arrows, and then you can actually control the way that the arrow flows. You can control how it flows. And you also have some controls over what happens in your tools that you have to control. You have to set those or set them up so that they can be responded to by prompts if the tool is running. And so what you're doing is you're actually creating a new tool here. Okay, it's a specialized tool because this one works with particular data and it only does it does a couple things that individual tools do by them, could do by themselves. You could step through the process yourself and do this, but this will do it, should do it all in one sort of whack, you might say. So let's see if it goes. I'm going to validate again, just to make sure everything's fine. And you can see here's this should be our map. I'm fooling around with it now. I'm going to screw it up. Okay, I'm going to validate, and then I'm going to run the model. What happened to my contents over here? I think I actually here. Let me try this again. Oh, remember that time the teacher did something and it didn't work in class? Why isn't that open? Yes,
I believe you're supposed to close it and then open it back up.
close the
The
model?
whole thing. The whole thing, like the program itself.
Oh, the whole program.
Yeah.
I don't know. I'll try that. No, not really. There's a different model in there. Oh, I want the same one that I had. Okay. Yeah, I can try that too. How you guys doing? Is everybody hanging on? I'm almost done here. This was the last thing I was meaning to do. Thanks for the tip. Was that Jillian? Sounded,
No, it was me.
it was who?
Me,
I can't
Nora.
Oh, okay, Nora. Thank you, Nora. Yeah, so I think it's this one here. I think it is. Yeah. I think it is or not. If it doesn't work within the next couple of minutes, I'm going to show you next week. Might take me another week to straighten this out. Which one was it? Was it 7 or 12? No, that's too late. Two 16, nope. 924. Oh, 922, that's not it. 15. Well, you know what? I think I'm going to show you guys this, and I'll wrap this up next week. Does anybody have any questions or concerns at this point? Right now, you guys should be working on your activity 4s and you're certainly your activity 2s, definitely, probably first. And remember, I bumped that one up So you have an extra 4 points there with that, right? So the normal 8 points on an activity has been bumped up to 12 on activity 2. So there's 104 points on the table. Right? Has anybody got any questions or concerns you want to grant? Is that your hand up? Yeah, go ahead and unmute. Can you unmute yourself? Maybe I. Any questions, anyone? It's a great time to ask a question right now. Oh, 15. Questions, anyone? Anyone still here?
Yes,
Yeah, there we go.
I'm here. Sorry.
Yeah, just all of you guys unmute yourselves, please.
I guess, does it have to be a question about what we covered, or can it just be a general question that
No.
I've been?
Any kind of question.
Okay. Well, something that I've been trying to think about as we talk about all this, and as you were discussing the I guess the industries that and the organizations that gather, a lot of the data from the company here in Chicago. I guess my question is, so I think back to like IBM. Have they ever been a big player in GIS? Are they still a big player if they ever were? Or
No.
were they? No.
They haven't. Well, I say that, but I mean, IBM was founded by a guy who invented punch cards, I believe, that the census used to collect data back in the early 20th century.
Right.
So that, a lot of people who work in the history, and I work in the history of geotechnology, a lot of people point back to that. I think his name was Hollerith. So that was so far before GIS though, but it was really, I mean, the census has been central since the beginning of things that we actually recognize as GIS in the 1960s. The census has been central to collecting and formatting geospatial data in different ways. So all of their, the census had been into mapping for a long time, all the way down to census blocks. And they would produce atlases every 10 years, multiple atlases that were associated with the counting of people. So IBM, has been involved in processing information since the early 20th century, doing it with punch cards. And then eventually in the 50s, they had, some early electronic devices that were interesting, but they've never been a big player in GIS.
Okay. Yeah, I was just curious.
Other than having, having, like mainframe machines and mini computers and PCs that are used for, for doing that kind of work, but they've never really been a big player in terms of, developing applications that were mapping applications or, anything like that. It's always kind of come from outside of that. And now, Microsoft is a pretty big player. Apple is a huge player. Google is a huge player. And even some of the social media tech giants are very significant players in, and also the firms that built in the first wave of consumer GNSS devices. So Garmin, TomTom, they became big players because they started, collecting data. Here, the company that's here in Chicago, they were I prefer to refer to them as the company that was formerly known as Navtech. And they came out of the Silicon Valley,
Right.
but they, they moved to Chicago in the 90s, and because they're smart, and they have become huge. It's them and Telemap, which is a Dutch firm that was swallowed by, I think, by Nokia or one of the mobile phone companies. And
Okay.
so there's a duopoly for the street network in the world. Here they have a street network for the entire world. They have people working all over the world, driving around, trying to find a Starbucks in Mongolia. I mean, it's that crazy. And they're based out of a building in the West Loop. And we have students who've gone to work for them.
Well, I was just curious because it seems like IBM, at least from the outside looking in, seems to be involved in many different industries. So I was just curious if they were involved.
Yeah, you would think they would have been more. But once again, they kind of missed the boat on I think on GIS. The dominant firms are like, ESRI is very dominant, and Google, Apple have become data dominant. And firms like INRIX. INRIX is a huge firm. So it's a really heavily capitalized firm, but it's a huge firm, and they have I haven't really looked at their annual report, but I would guess that their annual sales are they have a lot of zeros on it, I would think, because they're selling to Google and Apple. And everybody that looks at their phone is looking at their data. When the green, orange, and red lines, they're looking at traffic. But I mean, there's a lot out there. There's an awful lot out there. But IBM, they haven't really, and GIS is it's not really that much of a hardware, industry. It's mostly data and software, and the hardware, the hardware now, I mean, what you see are things like UAVs, drones, and GPS and or GNSS and other types of sensors that are being used, like LiDAR, like light imaging, laser imaging. These are the hot hardware technologies that you see, that I see when I'm looking at the trade, magazines. And IBM, for better or worse, until relatively recently, I mean, they don't really, they've never been a software company. They've never really been a data company. They're a hardware company. They make computers. That's what they've always made. Back when the world ran on mainframes, the 3090s. That's what I started on. I think. Well, no, it was actually an 11750 DEC was where I really got involved. That was like a a mini computer. So there was this class of machines that were in between workstations and what they called mainframes back then. Now, it's all server farms. And I've told people this story, but I've heard this from reliable sources, that in places like, San Mateo, and where, there's these huge server farms, that everything that Google does, goes through these building, these campuses, these buildings that are just loaded up with servers, that the servers are organized physically within the building. It's like a world map, because when you make a query, most often you're looking for something that's close by you. And so the savings in the transfer time virtually at the speed of light that would happen by transferring to a machine that's closer physically on a large campus with lots of servers, it adds up. There's that many transactions, that savings in nanoseconds in a search, it makes a difference in the bottom line at the end of the day. So that's another way that, it's really all about space in the end. That's a good question, though. I hadn't really thought about that much. IBM. Any other questions?
Professor, quick question. For activity 2,
Yeah.
do you want us to choose tasks that have not been that have not had any features added to them yet on a specific section of
It really doesn't matter.
Okay, because I've been
I'll say that.
to,
Go ahead.
from
Sorry.
across a lot of them that have just been already touched by, just have added features and whatnot.
Yeah. I actually think it probably, when you're beginning, it probably helps to come in on somewhere where some people have already been working.
Okay.
So that does, there's a couple of reasons. The one reason is you get a chance to see the work that other people have been doing, and you're going to be doing similar kinds of work, and it can be tedious. I'm not asking you to do that much. Technically, you guys can do the minimum requirements for this in probably under an hour, but the idea is that it becomes a habit, and you kind of go back and you get kind of interested in the project. You want to see how it goes, and maybe even take on other roles, maybe be, do like checking, certifying other people's work, looking at other people's work and saying, yeah, that's good, that's good, that's good. And then even making, and each project pretty much has like a little kind of a talk section or something, or a community section where people can put comments in, and you can put comments in when when you post data, that kind of thing. If there's anything that you feel you want to share with, but it's a new thing. It's going to be a new thing to most of you guys, because it does involve image interpretation usually. So you have to look, if you get used to looking at vertical aerial images, which is, I've been doing it for a long time. So for me, it's like, I enjoy it, because it's almost like a puzzle when you look at it. You look at something, you go, what the heck is that? And you want to kind of try to figure out what it is that you're looking at, what sort of activity is going on, or what physical things, geomorphological things that are happening, in places. So, I would guess I would probably lean more on the side of selecting one that has some people that have already been working on it some. But there's still some places available to work.
Okay, sounds good. Thank you.
All right, sure thing. Who else? Anybody else?
I had a quick question about the traffic mapping we were talking about with probe
Uh-huh.
vehicles. I
Yeah,
was wondering, like, are those like, do car manufacturers have like deals with like INRIX to provide data from their vehicles? Like, is that data directly from vehicles, or how does that work?
that's a good question. I don't think that, I think that once you purchase a car, if you lease a car, it may be different. If you purchase a car, the deal would have to be with you legally to share your data, even anonymized data. I think most of the probe vehicles are like fleet vehicles. So they're cabs, if there's still some of those, like Uber, Lyft, and delivery vehicles like Prime. And it's a way for them, like they sell the information, they get paid for the information, the owners of these fleet vehicles, UPS, FedEx. So they, these vehicles are all over the place. You see them all the time, right? And so roads get updated as one of these probe vehicles drives over the road. It's updating the speeds that you can travel on segments, and they're all segments connected between, what's the word? They're points at the end of lines in a highway network, nodes. So each segments, like when you look at a traffic map, they're in segments. They're not, it's not, you see that it changes like from orange to green, as it does it immediately, right? And that's where where two lines come together at a node, a point, a vertex. So each segment is an individual feature in an attribute table. And they're updating in real time. That's why I put this as real time. They're updating in near real time. They'll look at like the metadata behind those traffic maps is how, the most important metadata is how long has it been since this segment was updated.
That's super interesting. Thank you.
Well, you said if you're interested in that, you should because it's a huge industry, and it's an interesting industry. Here is a great company to work for. A number of our graduates have gone to work there, and I know people who've been working there more than 10 years, and they're really happy. Some of them travel. Some of them travel all over the world. Some of them have like regional responsibilities. So there'll be like supervisors of people who travel, but they're also here, like Google is also collecting basically like street view data. So, and they're doing it with LiDAR and cameras. So they have I've seen one of their vehicles. One of the here people brought one of the vehicles out to I'm in this group of, it was URISA, the Urban and Regional Information Systems Association, which is based in Des Plaines, Illinois. Their national headquarters is in Des Plaines, Illinois. So we have these occasional meetings over there. And actually I was able to ride my bike to the national headquarters for URISA, which is a big, planners organization. URISA is URISA.org. If you ever want to check into that. And it's sort of like the planning GIS organization. It's been around for 60 or 70 years. But they brought one of their vehicles out, and we got to kind of get inside of it and look and see how it works. And they have these two like huge decks in the trunk that will store, they can drive for like 2 weeks and record data, record video and LiDAR. And the LiDAR, they're making 3-dimensional models of everything from the center line of the street out to the first building on the, so the yard and the whatever, the garden, front garden or whatever, and the curb, the curb gets mapped all in 3 dimensions. And then they drape the, for imaging. I mean, that's what they do with Streetwise, is they drape, frames on a LiDAR 3-dimensional model of trees and parked cars. They screen those out in the LiDAR data. Those get, cut out of the data. Good
Yeah, I
question.
remember the Google
ahead.
Street View first came out a long time ago, and it was just sort of like a bunch of stitched together images. I imagine nowadays that you could build like a 3D model of a whole street system.
Yeah, and Apple's doing the same thing. They're doing it themselves. We have graduates working for Apple Maps in Northern California.
Yeah, that's
Nice
super
place.
interesting
Yeah, nice place.
for sure. Thank you for all the tips. I appreciate it.
Yeah, sure. Who else? Anybody else got a question or comment?
Well, I think I should wait.
Okay. Well, if you guys don't have any questions, you can take off.
Thank you. Have a good night.
Thank you.
Okay.
Thank you, Professor.
Thank
All right. Take care, y'all.
It's like a quick comment. My bad
Oh.
about sending the email about the Minnesota Hennepin County map, but then not following up, because I kind of just looked at the activity after that, and I kind of just like finished it, went all the way and finished it for Cook County. So
Oh, the one, oh, did you?
yeah.
I'll take a look at, did you just submit it or?
I think I submitted it the day I sent the email, actually, because I kind of just
Was there
started.
not,
Yeah.
was there not, I haven't gotten into, my teeth into the grading of that, but was there not that much going on in Minneapolis or in Hennepin?
No, I just
Yeah.
on the directions to
remember.
contact you about getting like the data for the
Uh-huh.
county. If we were gonna pick a different spot.
Oh, yeah, Hennepin is in the folder.
Oh,
That's
yeah,
what
I'm
I wrote you
sure.
back.
Yeah, I'm
So
probably. I'm for sure
this
it
is-
definitely is, but
No,
just
it
like-
is. It's
yeah.
because there's students that have done that before, and I've collected it and I've saved it. So it's the 2010 data though, but I actually have the 2020 data, the census data for 2020 for the whole nation.
Ooh.
But it's a service. So I'm trying to figure out how to share. I want to extract, the counties that people need so that you have a feature class or a geodatabase or something, rather than having to use service credits, because that's kind of how it works. It's like we have a certain number of credits that we can use to connect to these big data sets. And this is a big ESRI data set that they have. It's really not getting used that much, but I thought it would have been used more. It's the redistricting file. It's a mess. It's an absolute mess. If you think the data for the 2010 census, it's like this shining beacon of light.
Clean compared. Oh Lord.
Well, it's clean, but it's the problem that I find with it's like we sort of predicted this when they started going to it's this fascination and focus on race, and it's like you could take a matrix, and they go about six races deep or something like that, and so and then you have
I mean, yeah, there's definitely
Hispanics,
more.
that's not a race. So you have attributes for people people who declared themselves mixed, multiracial, 2 races. You have attributes, also all the completely separate set for people who declared themselves multiracial with 3 races, 4 races, 5 races, and 6
Oh,
races. So you have a complete set for each one of those possible racial or ethnic. It's this focus on race, which it's turned the census data, I think, into kind of a morass in a way. It's like, how do you have to
what's
to
a
make
morass?
sense out of it. It's like, I mean, I think it's wonderful that people can identify as they're for what they believe and they feel that they're comfortable with as people, as humans, But for people that work with the data, man, it's a real mess. And you'll see it because I'm going to at least share the Cook County data, the 2020 data. And it's possible you could take it and do some comparison, between 2010 and 2020, but I don't know. But it's nice to have, since the TRI data we have is 2020 data now, to have the 2020 census with that, it fits. So you can say definitely, there were, 7,489 children under 5 within a mile of this facility that was, releasing this much lead into the air or water or soil. So it's a data moment right now. We have the 2020 TRI and we have the 2020 census, and it's as fresh as it's going to get right now. So it's
Well, yeah, and just having
be
it like
good.
now, not actually in 2020 is just so like, realistic. It's like, of course, yeah, you don't get the info right as like
Yeah.
the year turn 2020. It's just like,
Well,
okay.
it's been out for about 5 months. It's been available for about 5 months.
But even still, there's been lots of real-time data.
But they sent it to the state legislatures, and they would in the states, they share that with local governments for redistricting. So they share all that data was out in the hands of it was in the public's hands, but it was in like state legislatures, and they were, they have committees and they're hiring consulting firms to sort the data out, sort the census data out and produce results, produce this, new congressional districts and all the other, minor electoral divisions that happen in redistricting.
I see. So the government hoopla of all the things that they have to hoops that they have
That's
to
what
go.
it's the first thing it's used for. Probably.
Mhm.
Yeah, it is. It's the first thing it's used for is for redistricting. And redistricting is a horrible sort of thing, I think. But it is what it is.
All right. Well, thank you for class. That was
All right,
fun.
sure
It
thing,
was good
Roger.
last night. I did it while I was working out. It was nice. So I listened to a podcast.
Oh,
But
cool.
yeah, peace out.
All right, sweet. Take care. All right, Grant, what's up, man?
First of all, I went to the bathroom and when I came back, I saw you've been asked to participate.
Here, I'm gonna stop recording.
Okay.
Sorry, I forgot. Just as we were